Hello friends, myself R.D. Mahajan presenting my video on Z transform topic solution of difference equation by Z transform technique. First of all, I will define what is by difference equation. Any equation containing the terms f of n plus 2, f of n plus 1, f of n and f of n minus 1, f of n minus 2, etc. is called as a difference equation. And its solution is nothing but any expression containing f of n in terms of n is called as its solution. And to find out the solution, we have to remember some standard result. The first one, Z transform of f of n is f bar of z. Second, Z transform of f of n plus 1 is equal to z f bar of z minus z f of 0. Then third, Z transform of f of n plus 2 is equal to z square f bar of z minus z square f of 0 minus z f of 1 and so on. Next, Z transform of f of n minus 1 is z raised to minus 1 f bar of z, means inverse Z transform of f bar of z, and Z transform of f of n minus 2 is equal to z raised to minus 2 into f bar of z and so on. Therefore, these are the important results to obtain the solution of difference equation by Z transform. And whenever we require to find the solution of difference equation by Z transform, there are two major parts. In the first part, we are applying Z transform, and in second part, we find the inverse Z transform to get that f of n. How? I will explain with one simple example. Example number 1. First example, solve difference equation f of n plus 1 minus 2 times f of n is equal to 0, and with the condition f of 0 is equals to 1. And therefore, here the given difference equation is f of n plus 1 minus 2 times f of n is equal to 0. Transferring this term to right hand side, we get f of n plus 1 is equal to 2 times f of n. Then next step, taking Z transform on both sides, therefore capital Z of f of n plus 1 2 times Z transform of f of n. Then applying this standard result, whatever just I have explained, its Z transform is Z f bar of z minus z f of 0, and that is equal to 2 times Z transform of f of n is f bar of z. Then collecting the terms of f bar of z on left hand side and other terms to right hand side. Therefore, there are two terms of f bar of z. Taking common f bar of z, we get z minus 2 into f bar of z is equal to f of 0 is 1. Therefore, minus z, if we transfer, it becomes plus z. And then dividing by z minus 2, we get f bar of z as z upon z minus 2. Equation 1. Here the half part is completed. I have obtained the Z transform of the given difference equation to get some expression for f bar of z. And then in next half part, we require to find out its inverse Z transform by residue technique. And therefore, next is taking inverse Z transform. Taking inverse Z transform of applying the steps. First step is find the pole. Equating this term to 0, we get z is equal to 2 as simple pole. Then multiply it by z raised to n minus 1, we get z raised to n minus 1 into f bar of z, that is equals to z raised to n minus 1 into z upon z minus 2, nothing but it is z raised to n adding the power of z and divided by z minus 2. And then obtaining the residue at that pole, z is equals to 2, we get. The type of the pole is a simple pole, and therefore applying the first formula to find out the residue at the pole z is equals to 2, we get, as per the formula, it is z minus a is here 2, multiplied by this term, that term is z raised to n, and whole divided by z minus 2 at z is equals to 2. This z minus 2 get cancelled, and therefore substituting the value of z as 2 here, we get as 2 raised to n, and therefore solution is f of n is equal to sum of the residues. Here only one residue, and therefore we get that solution as 2 raised to n for the condition n greater than or equal to 0 as a required answer. And therefore the final solution is f of n is equal to 2 raised to n for the condition n greater than or equal to 0. Remember these two different parts. In part 1 we have to apply Z transform technique, and in part 2 we require to apply inverse Z transform technique to obtain this f of n. One more I will discuss in my next video. Like my video, share it, as well as subscribe to my channel if you are not subscribed yet, and press the bell icon to receive the notification for my all new videos. Thank you. Thanks for watching.